Hello everyone and welcome to our channel Bibliophobia. The Universe in a Nutshell is a book by the renowned theoretical physicist Stephen Hawking. Published in 2001, this book is a follow-up to his earlier work, A Brief History of Time. In The Universe in a Nutshell, Hawking takes readers on a journey through the complex and fascinating world of theoretical physics, cosmology, and the nature of the universe itself. Throughout its pages, Hawking tackles profound questions about the cosmos, the nature of reality, and the fundamental laws that govern the universe. He does so in a way that is accessible to the general reader, using plain language and clever analogies to elucidate complex ideas. This essay will delve into the key themes and concepts presented in The Universe in a Nutshell, providing a comprehensive overview of this enlightening work. Chapter 1: Brief History of Ideas about the Universe. Hawking begins by tracing the historical development of our understanding of the universe, from ancient civilizations to the modern era. He highlights the contributions of great thinkers such as Aristotle, Ptolemy, Copernicus, and Kepler, who paved the way for the revolutionary ideas of Galileo and Newton. One of the central ideas discussed in this chapter is the shift from a geocentric, Earth-centered, to a heliocentric, Sun-centered, model of the solar system. This shift was a watershed moment in human understanding, as it marked the transition from a universe where Earth was at the center of everything to one where Earth was just another planet orbiting the Sun. Hawking also introduces the concept of the scientific method and how it has played a pivotal role in advancing our understanding of the cosmos. He emphasizes the importance of observation, experimentation, and the formulation of testable hypotheses in the pursuit of scientific knowledge. Chapter 2: The Nature of Space and Time. In this chapter, Hawking delves into the nature of space and time, two fundamental aspects of our universe. He introduces the theory of relativity, which was formulated by Albert Einstein in the early 20th century. There are two forms of relativity, special and general. Special relativity, presented by Einstein in 1905, deals with the behavior of objects moving at constant speeds, particularly those moving close to the speed of light. It introduces the famous equation E equals mc squared, which relates energy, E, to mass, m, and the speed of light, c. General relativity, developed by Einstein in 1915, is a theory of gravity. It posits that massive objects, such as planets and stars, warp the fabric of space-time around them. This warping effect causes objects to move on curved paths, which we perceive as gravitational attraction. Hawking explains these complex concepts using relatable examples and analogies, making them more accessible to the lay reader. He also discusses the implications of relativity, including time dilation, the slowing of time in strong gravitational fields, and the concept of black holes. Chapter 3: The Shape of the Universe. In this chapter, Hawking explores the geometry of the universe. He introduces the idea that the universe can have different shapes, open, closed, or flat. These shapes are determined by the overall density of matter and energy in the universe. Hawking explains that the geometry of the universe is intimately connected to its fate. An open universe will continue to expand forever, while a closed universe will eventually stop expanding and contract, possibly leading to a big crunch. A flat universe represents a delicate balance between expansion and contraction and is often associated with the idea of a universe that will expand forever but at a gradually slowing rate. The concept of cosmic inflation is also discussed in this chapter. Cosmic inflation is a theory that suggests that the universe underwent a rapid and exponential expansion in the moments following the Big Bang. This theory helps explain various cosmic observations, such as the uniformity of the cosmic microwave background radiation. Chapter 4: The Quantum Universe. Moving from the macroscopic scale of general relativity to the microscopic scale of quantum mechanics, Hawking delves into the strange and counterintuitive world of quantum physics. Quantum mechanics is a branch of physics that deals with the behavior of particles at the smallest scales, including atoms and subatomic particles. It is a realm where particles can exist in multiple states simultaneously, where observations can affect outcomes, and where uncertainty reigns. Hawking introduces the concept of wave-particle duality, which describes how particles like electrons can exhibit both wave-like and particle-like properties. He also discusses Heisenberg's uncertainty principle, which states that certain pairs of properties, such as position and momentum, cannot be precisely measured simultaneously. One of the central ideas in this chapter is the concept of virtual particles and the vacuum fluctuations that occur in empty space. These fluctuations give rise to a variety of phenomena, including the Casimir effect and Hawking radiation, which will be explored in more detail later. Chapter 5: The Theory of Everything. The quest for a theory of everything (TOE) has been a holy grail of theoretical physics for decades. It represents a unified framework that would encompass all known physical forces and describe the fundamental laws of the universe in a single, elegant theory. Hawking discusses the history of attempts to unify the fundamental forces of nature, focusing on electromagnetism, the weak nuclear force, the strong nuclear force, and gravity. He introduces key figures in this quest, such as James Clerk Maxwell, who unified electricity and magnetism, and Albert Einstein, who sought to unify gravity with the other forces. The chapter also delves into the challenges of unification, including the vast differences in the strengths and behaviors of these forces at different scales. Gravity, for instance, is extremely weak compared to the other forces, making it particularly challenging to unify with them. Hawking introduces the concept of superstring theory, a promising candidate for a TOE. Superstring theory posits that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. These strings can vibrate at different frequencies, giving rise to different particles and forces. Chapter 6: Black Holes and Time Warps. Black holes are one of the most enigmatic and captivating phenomena in the universe, and Hawking dedicates a significant portion of the book to exploring these cosmic mysteries. He begins by explaining how black holes form when massive stars collapse under their own gravitational pull. The core of the star implodes, and if it is above a certain critical mass, known as the Schwarzschild radius, it becomes a black hole, a region of space where gravity is so intense that not even light can escape. Hawking introduces the concept of event horizons, the boundary beyond which nothing can return from a black hole. He explains how the laws of physics, as we understand them, break down at the singularity at the center of a black hole, making these regions some of the most mysterious places in the universe. One of Hawking's most groundbreaking contributions to physics is his theory of Hawking radiation. He explains how, contrary to the belief that black holes only consume matter and energy, they also emit a form of radiation due to quantum effects near the event horizon. This radiation gradually causes black holes to lose mass and eventually evaporate, a phenomenon that challenges our previous understanding of black holes. The chapter also touches on the concept of wormholes, hypothetical shortcuts through spacetime that could potentially allow for time travel. While the existence of wormholes remains purely speculative, their inclusion in the book adds to the sense of wonder and exploration of the unknown. Chapter 7: The Direction of Time. Hawking delves into the intriguing topic of the arrow of time in this chapter. Time, as we experience it, has a clear direction. It flows from the past to the present to the future. This apparent irreversibility of time is a puzzle that has fascinated physicists and philosophers alike. The concept of entropy plays a central role in understanding the arrow of time. Entropy is a measure of disorder or randomness in a system. The second law of thermodynamics states that in any closed system, the entropy tends to increase over time, leading to a more disordered state. Hawking explores how the increase in entropy gives rise to our perception of time's arrow. He discusses various thought experiments, such as Maxwell's demon, which seem to challenge this arrow but ultimately do not violate the second law of thermodynamics. The chapter also touches on the concept of imaginary time, a mathematical concept that Hawking introduced to reconcile the seemingly irreconcilable theories of relativity and quantum mechanics. Imaginary time is a way of representing time as a dimension that behaves differently from the time we experience, potentially providing a bridge between these two fundamental theories. Chapter 8: The Universe in a Nutshell. The titular chapter of the book brings together many of the concepts and ideas presented throughout the previous chapters. Hawking discusses the grand synthesis of science and how we might arrive at a coherent understanding of the universe. He revisits the idea of a theory of everything, TOE, and how it might unify the four fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. While superstring theory remains a leading candidate for a TOE, it is a theoretical framework that has not yet been definitively proven. Hawking also discusses the anthropic principle, a controversial idea that suggests the universe's physical constants are finely tuned to allow for the existence of intelligent life. This principle raises profound questions about the nature of our universe and whether it is unique or one of many in a multiverse. The chapter concludes with a discussion of the possible future of science and the exploration of the cosmos. Hawking encourages continued scientific inquiry and exploration as a means of understanding the universe and potentially discovering new phenomena and laws of nature. Chapter 9, Conclusion. In the final chapter of The Universe in a Nutshell, Hawking reflects on the overarching themes of the book and the wonder of the universe. He emphasizes the importance of scientific curiosity and exploration, urging readers to embrace the mysteries of the cosmos. Hawking also acknowledges the limitations of our current knowledge and the possibility that there are still profound secrets of the universe waiting to be uncovered. He highlights the role of science in expanding our understanding of the cosmos and how it enriches our lives by allowing us to explore the unknown. The book concludes with a sense of optimism and a call to continue the quest for knowledge and a deeper understanding of the universe, leaving readers inspired to embark on their own intellectual journeys. Conclusion. The Universe in a Nutshell, by Stephen Hawking, is a captivating exploration of the cosmos, from the smallest scales of quantum physics to the vastness of black holes and the nature of the universe itself. Through its pages, readers are treated to a tour of some of the most profound and enigmatic concepts in physics and cosmology. Hawking's ability to distill complex ideas into accessible language and thought-provoking analogies makes this book an invaluable resource for anyone seeking to understand the universe. His insights into the nature of space, time, black holes, and the quest for a theory of everything are both enlightening and thought-provoking. As we journey through the book, we are reminded of the deep interconnectedness of science, philosophy, and the human quest for understanding. The Universe in a Nutshell serves as a testament to the enduring human spirit of curiosity and exploration, inviting us all to join in the adventure of unraveling the mysteries of the cosmos.